So let's apply the binomial series expansion. But before I get started on that, I forgot to mention that this binomial series expansion works for any value of p, not just positive integer values of p. But when you do have a positive integer value of p, the binomial series expansion gives you the same thing you would get if you expanded this, by hand. But I'm going to leave that. That's going to actually be, there's going to be a homework problem um, where you get to kind of explore that homework problem to explore that how that works when p is a positive integer. But let's go on to this example 2. Now, I think I'll do examples 2 and 3 together because they're really related. What I want to do is just compare the Taylor series expansion of this 1 over x plus 1 to the binomial series expansion, which you would expect they'd be the same. So let's do that. Let's just do a little trial and make sure that our binomial expansion works the way we were predicting it to. So if we were to do the Taylor series expansion for this, we have f of x equals 1 over 1 plus x, which is the same thing as 1 plus x to the minus 1 power. Okay, so and f of 0, when we put in 0, we get 1. Okay, we're going to need that. So let's just start taking derivatives. So the first derivative of the function is minus 1, 1 plus x to the minus 2. All right, and so when we put in 0, f prime of 0 is equal to minus 1. The second derivative is going to be 2, so minus 1 times minus 2, 1 plus x to the minus 3. We plug in 0, and we get 2. All right. The third derivative is, we're going to take 2 times minus 3, so we get minus 6, 1 plus x to the minus 4. And the third derivative at 0 is just going to be the minus 6. All right, so that's probably enough. So that tells us that 1 over 1 plus x is equal to, all right, so we're going to start with f of 0, which is 1. And then we have minus 1 times x, so it's going to be minus x. And then plus the second derivative at 0, which is 2 over 2 factorial x squared. And then minus third derivative is minus 6, so that's where I'm going to get the minus. So I'll have 6 over 3 factorial x cubed, and that's enough. We got 4 terms, that's plenty. And so I can simplify this a little bit because you see obviously that 2 factorial is 2, so this will cancel. 3 factorial is 6, so this will cancel. So it cleans up really nicely, right? We get 1 minus x plus x squared minus x cubed, and so on. And that is our Taylor series for that 1 over 1 plus x. So let's take a look at just taking that same thing and applying the binomial series expansion. All right, so like I said here, 1 over 1 plus x is just 1 plus x to the minus 1. So we have p is equal to minus 1. And so we can just plug that in to our expansion formula that we found, the binomial series expansion formula. So we get 1 plus x to the minus 1 power then is equal to 1 plus p, so that's minus 1, times x. And then plus, we have p times p minus 1 all over 2 factorial x squared, and then plus p and p minus 1 and p minus 2 all over 3 factorial x cubed, and so on. And then of course we can clean that up a little bit, and you'll see it's just the same thing as we got before. So we've got 1 let's back up. That's going to be minus x. I'm just going to get rid of that plus and minus 1 and make it minus x. And then minus 1 times minus 2 becomes positive 2 over 2 factorial, which is just 1. So we have x squared. And then this will clean up to just minus 1 times x cubed. So minus x cubed. And so we get the same thing. Yay. All right, so I have a problem here for you to try. Just give it a try. And then you can watch the video or if you have any trouble with it, or just to confirm that you got it correct. So I'll see you in the next video.